Hi, today we'll be discussing the problem of the day, which is queue using two stacks. The problem statement is pretty simple. So what you have to do is you have to implement a queue using two stacks S1 and S2. A query queue is of two types. One X, that means you have to push X into the queue, and two, which means you have to pop from the queue, right? So what is a queue? Firstly, what is a queue? A queue is actually a data structure which is first in, first out, right? First in, first out, as in first in first out, as in the element which will be inserted first, it will be removed first as well. Whereas a stack is a data structure which is last in first out. The element that is inserted last will be removed first from the stack. So you have to convert, you have to create a queue using two stacks, and that is using the stacks, you have to support two stacks, you have to support the FIFO principle, right? So let's take an example. So 5 1 2 1 5 1 2 1 3 2 1 4 2. So 1 2, first is 1 2, query is 1 2. You are inserting 2 into the stack. After that you have 1 3, you are inserting 3, sorry, you are inserting 2 into the queue. After that you are inserting 3 into the queue. After that you are popping 2, right? You are popping an element. So what is the queue? A queue is first in, first out, right? So the element that is inserted first will be removed first as well. So 2 gets removed because 2 is inserted first, right? So 2 is removed, and after that you are inserting 4 into the stack and then popping. Now let's actually understand this. So we have, we are inserting 1 2. After that we are inserting 1 3, that is we are inserting 3. After that we are popping, that is 2. After that we are inserting 1 4, and after that we are popping again, right? So what is happening in the queue? First 2 is inserted into the queue, so 2 is inserted into the queue. After that 3 is inserted into the queue, so 3 gets inserted here. Now we are popping an element. Which element gets removed? The first element that is from the front of the queue. So this element is removed, right? So this element gets removed. So let's remove this 2 and this. So we have removed 2. Now we have only 3 left. Now we are inserting 4. So 4 is removed. Now we are popping again. Which element will be popped? 3, because 3 is inserted before 4, so 3 gets popped, so 3 is popped, so the answer will be 2 3. Now we have to implement this queue using two stacks, right? One additional thing that is given to us is that we can the estimated complexity will be order 1 for push or order n for pop, or the other way around, like order n for push and order 1 for pop. So we have to do this, and auxiliary space we should not take, we should just take two stacks that is given to us. So we have to implement this. How can we do this, right? So there are multiple ways we can actually do this. Obviously there are two ways, as already mentioned in the constraint, that we can either have two order in push or order in pop, right? So first of all, let's talk about order in push, right? What can we do? So what we have to do is we have to maintain, we know that the stack is a last in first out, right? LIFO principle. So the last element will be removed first, but we have to support FIFO, right? So what do? We do is we always have to order the stack in a way, whenever we are pushing into the stack, we have to keep the first element on the top. The first element that was inserted, it should always be at the top, right? So let's insert a few elements, 2 3 4. Let's say we are inserting 2 3 4 into the stack, and we have two stacks, right? What can we do? First, when we are coming to 2, we can just insert 2, right? Now when we are coming to 3, 3 will be inserted on top of 2, right? So what we'll do is we'll pop everything out. We'll pop everything out. That is, we'll move the 2 to this point, right? We'll move the 2 here. Now we will push 3 into this stack. We'll push 3 into this stack. Now we will again empty this second stack back in the first stack. Like we'll take one element out, that is 3 is taken out. It goes down and it is removed from the second stack. After that 2 is taken out and it goes here, right? 2 goes here. So now see that the element that is coming first, that is 2, is on the top of the stack, and we are actually supporting. Now if we are popping from the stack, that is, if we are popping the top element, it is indeed the first element that was inserted. So it is indeed, it is becoming FIFO like this, right? So again, let's take 4. We are inserting 4, right? First we'll empty the stack S1 into the stack S2, right? That is, we'll take one element from the top and insert, right? Like that will empty. So we're taking the element from the top, that is 2 is taken away. 2 is inserted into S2, right? After that 3 is taken away. 3 is inserted into S2. Now we will insert 4 here again, right? We'll insert 4 into S2. Now we will empty S2 into S1 again. So 4 is taken out first. So 4 comes in S1 at the bottom. After that 3 is emptied, so 3 is coming after that, so 3 comes here, and after that 2 is emptied, right? After that 2 is emptied, so 2 comes here. Now if you pop from the stack, you can just remove the topmost element, or pop from the queue, you can just remove the topmost element, and that is indeed the front element of the queue, right? The first element that was inserted. So this is how we can do it in order of n. Insert operation, that is a push operation, or we can call it nq as well. Order of n push and order of one pop, right? Order of n push and order of one pop, because in pop we are just removing the topmost element. But here if we see, there are two loops that we need. First we have to empty s1 into s2, that is the first loop that we need. After that we have to empty s2 into s1, that is the second loop that we need, right? So we are actually having a 2 into n complexity, not a n complexity. But in asymptotic analysis it becomes order of n, so that's why it remains the same. The better way, just by using, if we just want to use a single loop, the better way will be to have a order of n pop operation and order of one push operation, right? Let's see how we can do that. So let's clear this board quickly. Okay, so we have two queues, right? Let's say we are inserting 2 3 4 and then we are popping, right? So when we insert, we will just directly insert into the first stack, right? So, or let's do something like this: 2 3 after that pop, 2 3 4 after that pop, after that we insert 5 and then we pop again. Let's follow this, right? So first two, when we are inserting, we'll always insert into s1, right? We'll always insert into first stack. So we are inserting 2 here. After that we are coming to 3, insert, so we'll insert in the first stack 3. After that we have inserting 4, 4 will be there in the first stack. Now when we come to pop, we cannot remove the top element, because then it will become as same as a stack. The last element inserted will be first to be removed, so we have to remove the first element, right? So what we'll do is, now we will empty into the second stack. We'll empty into the second stack. So 4 is emptied, 4 comes here. After that 3 comes here, 3 is emptied. After that 2 comes here, 2 is emptied, and we print, and we will print the top of the stack, that is, we'll remove the top of the stack, that is of the second stack is 2, that is 2. 2 is removed, right? And indeed 2 will be removed, right? So 2 is removed here. Now we do not empty back s2 into s1. We do not need to do that. Why? Let's understand. What s2 contains is basically the first few elements, right? Whatever is pushed into s1 round will be coming after what is there in s2, right? Whatever s2 has, after that it will be coming. So we don't need to empty it back again, right? So if we're inserting 5, we can just safely insert 5 here. And then we can, when we get a pop, we can just see if s2 is not empty, we can remove the top element of s2, right? 3, that is 3 is removed, and indeed 3 is the second element that was inserted, right? So we don't need to empty. Let's do a few more operations. So let's say we do a pop again, or we don't do a pop again. Let's say we do a push, of 6, then we do a pop again, and then we do a pop again, right? Something like this. So now we are pushing into the pushing. So whenever we push, we will push into s1, right? We'll push into s1, that is 6 will come here. Now we have a pop operation. What do we do in during a pop operation? We know that all the elements that are there in s2, they have come before what is there in s1, right? They have come before s1, so we can remove from here, from s2, as long as it is not empty. So we'll remove from s2, and now it is empty, right? And if you see, 4 was indeed the second element, third element that was inserted, so 4 is removed. After that we are again popping, right? After that we are again popping, but we see that s2 is empty. So what do? We again move from s1 to s2. We again transfer the elements. So 6 is removed and pushed into s2, and after that 5 is removed and pushed into s2. And this is much better complexity. Why? Because in worst case it will be order of n, yes, but if you see, once the elements are moved into s2, they are just popped one by one. They are not moved back again into s1, right? They are not moved back again. And again, so there is only one loop that is running as well. So it is one loop plus we will not always have a order of n complexity for pop. If some element is there in S2 already, we will just simply pop it in order of 1 complexity. So that's why it is much better asymptotically than the previous approach, right? So this is order of n pop and order of 1 push, right? So this is how we can convert two stacks into a queue. So let's write the code for this. We'll go to this part. Okay, void push, we have to push into so we'll take C++ here. Okay, push, what do? We just push into S1, right? So S1 dot push X. Now here what do? First we check if both are empty, right? If X1 dot empty and X2 is also empty. Sorry, not X1, S1, my bad. S1 is empty and S2 is also empty. That is, there is no element in the stack, right? In the queue. So we cannot, it should return a -1. So empty, we should return a -1. Now, first condition is if not S2 dot empty. If S2 is not empty, in that case, what do? Int TP equals to S2 dot top, and we can remove the top element S2 dot pop. Right, now we can return TP, that is the top element. So this is order of 1, right? If S2 is not empty, it is order of 1 for us. So otherwise, if it is empty, then it will be order of n, right? Then it will be order of n. So if it is empty, what we can do is we have to empty S1 into S2. So while not S1 dot empty, S2 dot push S1 dot top and S1 dot pop, right? So we'll empty S1 and we'll take the top element in TP equals to S2 dot top, S2 dot pop, and we can return TP. So return TP. So this will become order of n. This part, this else part will become order of n when H2 is empty, right? So let's compile this and see if this is working. So we have output a 2 3 and expected is 2 3. So let's submit this. Okay, it's completed. We have got it has passed. So this is how we can actually solve this problem, and it was pretty simple. Like, it has already been tagged as easy, so it was pretty simple. It's just a trick. Like, you have to realize that a queue is first in first out and stack is last in first out. So how do you make the stack support last in first out if you have two stacks, right? So either you can, in the enqueue operation you can do that, or in the dequeue operation you can do that, right? So that's about today. Thank you for watching.